In this video, we're going to discuss ordering numbers or putting numbers in order from least to greatest. And so what I want to do is I want to consider this set of numbers that I have up here, and I'd like to actually graph these. But first things first, let's consider how might a person actually put numbers in order from least to greatest. And when we consider least to greatest, let's think about this, because I get a lot of kids that will mix it up sometimes. And say I were to grab a pencil, and I say, okay, -7 and 6, and I say, well, which one's bigger? And they have no issue telling me, well, in terms of magnitude, -7. So, but they confuse magnitude, which is size, with like kind of, I don't want to say displacement, which is direction. But when you think about -7, it may be bigger, but it's also less than 6. And the reason why, we talk about ordering numbers, is actually putting them on a number line. So when I said graph the following numbers on the real number line here, what I'm implying is that if we can put these on a real number line, then we could, have them in order, because we could read them from left to right. So first thing we're going to do is kind of review a couple quick vocabulary terms. But we say a point on a number line that corresponds to a real number, we say that is the graph of that number. So we're going to be graphing all of these numbers on this number line that you see I've got constructed here. But we say drawing the point is called graphing the number. Of course, we're going to graph those, or plotting the point. But we say the number that corresponds to the point on the number line is called the coordinate of the point. So we're going to graph all these numbers, but these are the coordinates of each individual point that we're going to put on this number line. So now, again, still, this question becomes, how could we put these on the number line? And I think that the first thing we want to kind of look at here is this. Let me grab this tool very quickly here. Let me see if I can get this to work for us. 1 second. There we go. There we go. I think this should work for us now. We'll see. But the origin down here, we want to look at the origin, which is 0. And we're going to consider 0 a neutral number. Okay, so when we say neutral, we mean that it carries with it neither a positive charge, we could say positive, or a negative kind of designation. So we say all negatives are on the left side, all positives on the right side of 0. So we could at least do this. We could say, looking at this list up here, we say -2, -7/3, and then we could say, like, I don't know, 0 is not on the list of numbers up here, but we could say we know that these are both negative. And in terms of which ones are positive, we could say, well, we know that the 5/2, the 0.75, and the, looks like we have a √7 up here, are positive. So in terms of put them in order, I don't know if I've got them in perfect order yet. What would make these a lot easier to compare is if they were all, say, written the same way. So you'll notice that we have, say, like an integer value here. It's kind of a whole number, but not because it's negative. But we say, all right, fraction, we've got a decimal here. We've got some irrational number, √7 over here. So what we're going to do is this. Why don't we just go ahead and shift all these into a decimal format? So what this means is we're going to grab our calculator here. This is probably the easiest way to take care of this. We could say, well, we know this is a decimal is -2. If we were to change -7/3 to a decimal, okay, that would be -7. So we'd have 7, and of course that's negative, divided by 3. But we get -2.33 repeating. So we have -2.33 repeating. 5/2, we could also say 5 divided by 2 is 2.5. We have 0.75. And then the √7 here, I have no idea what √7 is, but we can go ahead and get an approximation. We'll go out to 2 decimal places, but about 2.65-ish. And we're going to write that on there, 2.65-ish, because it was just an approximation. So if I'm going to put these numbers in order, what I can tell you now is it's a lot easier to do now that I have them written this way. So we say, okay, on the number line, where would this number belong? Okay, well, it's the furthest to the left. It is the most negative. So -2.33 would be somewhere over here. It would be -2, and then about 1/3 of the way to -3. So we're actually going to label this. We're going to graph it. So we say, here's our point. We're plotting a point, or this is the graph of this coordinate, -7/3. And we're going to label this. Always label your graph, -7/3. Okay. So we know that that one's off my list. Well, -2 must come next. We say -2 is right here. We say, okay, well, this is -2. Next on the list, we have, well, I don't know. Let's decide. What's the biggest number here, the smallest number here? We say 0.75 clearly is the smallest of these, the least of the positives. So we say 0.75 would go right here. Of course, that's the same thing as 3/4. But we can list this as a decimal because it was given as a decimal. So 0.75 is gone. And then the next greatest would be 2.5, 2.5. And we would have to put a dot right here for the 2.65-ish. So we're going to label these appropriately. So for example, when I say 2.5, I'm going to label this as 5/2, because that's what we're looking for here. And we're going to label that 2.65-ish as root 7. So our task in the first place was to find a way to put these numbers in order from least to greatest, and we could just put them on the number line like this. We could say -7/3, comma, -2, 0.75, 5/2, and then root 7. We are using exact values here, no decimal approximations. We're labeling with what we were given. So putting these things in order, I'd say, one good note to have here is convert to decimal form when you have a calculator. So to convert to decimal, also this, separate the positives and the negatives. Separate plus and negative. That'll make it a little bit easier for you. But these two tips are really good tricks here. One thing I do want to mention though is this: we often compare numbers on the number line. So of course we have these in order from least to greatest, but we also put these symbols here, and we refer to these as inequality symbols. And then what we're implying here is this: when you see an inequality symbol, this is opposite. This is not the same thing as equals. This is, if we look up here, this is less than, greater than, less than or equal to, or greater than or equal to, but these compare. Okay, they do not say that the things on either side are actually the same thing. They are saying, something on one side is either greater than or less than the thing on the right. So when we talk about greater than or less than, the greater than always goes to the number that is furthest right on the number line when you compare those two numbers. So for instance, 2 and -3, what I want to do is I want to write some inequality symbols up here. We say 2 and -3. If we were to look on a number line, we'd say here's 0. We have 2 to the right. We say here's 2. Here's my graph of this. 2. And then -3. So we say, well, in terms of which one represents the greater of the two numbers, we say 2 because it's on the right. So we'd say since 2 is greater, it gets the fat or wide end of this symbol here. It looks like it's being eaten, I guess, is what you might have heard in the past. You'll notice the very next line, you say, well, this compares the same two numbers, -3 and +2. And absolutely right. Remember, we said 2 is the greater of the two, so it is on the right side in this case, so the wide end goes on the right side. So these two statements are the same statement. They mean the same thing. Moving on, though, we say -278, -279. A lot of the times people get this one wrong. They say, well, which one's greater? We say -279 just because it's bigger. But if we skip all the way out here, we say this is -277, -278, and -279. You would see that if we were to graph both of these numbers here, -278 is the greater of the two. Okay, so we say it gets the wider end. And then these two right here, hey, again, we could just pull out a calculator if we want to do this in decimal format. But we say 7 divided by 3. Looks like we have 2 1/3, so we say 2.33 repeating. And we are comparing this to 9/4. 4 goes into 9 twice. And a quarter, so we say 2.25. And in terms of which one is the greater than, it looks like we have 7/3 is the greater than. But how to order numbers, put them on a number line, graph them, and compare them. Cheers.